Welcome to the global defense battle.
The M2 Bradley Infantry Fighting Vehicle is an American armored vehicle designed to transport troops while providing fire support in combat zones. Developed by BAE Systems Land and Armaments, the Bradley was introduced into service in 1981 as a response to the Soviet BMP series of IFVs. It was created to replace the older M113 armored personnel carrier and to address modern battlefield needs, combining troop transport with heavy firepower and advanced protection. Its primary role is to transport infantry squads, offer cover fire, and conduct reconnaissance missions in high-threat areas. The M2 Bradley was developed during the Cold War era to counter Soviet armored vehicles, with emphasis on speed, firepower, and survivability. The Puma Infantry Fighting Vehicle, on the other hand, is a German IFV manufactured by Project System and Management GmbH, a joint venture between Krauss-Maffei Wegmann and Rheinmetall Landsystem. It officially entered service in 2015 as a replacement for the older Marder IFV, which had been in use since the 1970s. The Puma was specifically developed to meet the demands of modern asymmetric warfare, offering advanced modular armor systems, enhanced mobility, and state-of-the-art digital interfaces. Its primary purpose is to transport troops securely, provide direct fire support, and engage enemy armored targets. Talking about the design and dimensions first, the M2 Bradley has a length of 6.55 meters, width of 3.6 meters, and height of 2.98 meters. It weighs approximately 27.6 tons. The vehicle features a boxy, armored hull with a two-man turret mounted centrally, housing the commander and gunner. The driver is positioned at the front left of the hull, and a rear compartment accommodates up to 6 infantry soldiers. The Bradley's design incorporates spaced laminate armor, providing protection against small arms fire and artillery fragments. The driver is responsible for maneuvering the vehicle across challenging terrains and ensuring smooth mobility. In addition to the crew, the Bradley can transport up to 6 fully equipped infantry soldiers in its rear compartment. These troops can quickly dismount through a rear ramp door, allowing for rapid deployment in combat zones. In contrast, the Puma measures about 7.4 meters in length, 3.7 meters in width, expandable to 4.0 meters with additional armor, and 3.1 meters in height, extending to 3.6 meters with certain optical systems. Its weight varies between 31.4 tons in standard configuration and 43.0 tons with maximum armor protection. The Puma's design emphasizes modularity, featuring a stealthy, angular hull with advanced composite armor that can be augmented with additional protection as needed. The vehicle has a remote-control turret, reducing crew exposure, and is operated by a crew of 3, with space for 6 infantry soldiers in the rear compartment. The driver ensures smooth navigation across different terrains using the Puma's hydro-pneumatic suspension system. In terms of troop capacity, the Puma can carry up to 6 infantry soldiers in its rear compartment. These troops are seated in specially designed blast-protected seats, ensuring safety during transport in high-threat environments. Talking about the engine and performance, the M2 Bradley is powered by a Cummins VTA903T diesel engine, which generates 600 horsepower. This engine is paired with an Allison X 204 automatic transmission, providing smooth gear shifting and reliable performance on various terrains. The Bradley has a top speed of 56 km per hour on roads and offers good off-road mobility due to its torsion bar suspension system. With a fuel capacity of around 662 liters, it has an operational range of approximately 400 kilometers on a full tank. The Bradley's design prioritizes balanced mobility, offering dependable performance across rugged landscapes, but it falls short in speed and fuel efficiency. If we see overall, the Puma clearly outperforms the Bradley in engine power, speed, and range. The MTU engine's advanced design ensures better fuel efficiency and reduced operational costs over long distances, are relatively limited and dependent on preparation time and water conditions. On the other hand, the Puma boasts a next-generation fire control system that integrates digital ballistic computing, automatic target tracking, and programmable airburst munitions. Its optical and sensor systems include advanced thermal imaging cameras, high-definition day cameras, and laser rangefinders for exceptional target detection and engagement. The Puma's stabilized remote-controlled turret allows the crew to aim and fire while on the move with pinpoint accuracy. Its main weapon is the 30mm Mk32 ABM autocannon, capable of firing 200 rounds per minute and utilizing programmable airburst rounds for precision strikes on infantry and light armor targets. Additionally, the Puma is equipped with a 5.56mm MG4 machine gun, upgradable to a 7.62mm MG, and optional Spike-L are anti-tank guided missiles with a maximum effective range of 4,000 meters. These advanced missiles enable the Puma to effectively engage heavily armored enemy tanks from long distances. In terms of amphibious capabilities, the Puma lacks full amphibious functionality and cannot swim without extensive modification, which limits its flexibility in water operations. Overall, while the Bradley offers limited amphibious capability, the Puma focuses more on battlefield adaptability and firepower supremacy. Coming to the armor and protection, the M2 Bradley features space laminate armor, which provides protection against small arms fire, artillery shell fragments, and light anti-tank weapons. Over the years, it has been upgraded with explosive reactive armor kits, which offer additional protection against anti-tank guided missiles and rocket-propelled grenades. The Bradley's armor is designed to stop rounds up to 14.5 mm caliber and offers limited protection against 30 mm autocannon shells at certain angles. Despite these improvements, the Bradley remains vulnerable to heavy anti-tank weapons and larger caliber rounds, especially from modern tank guns. Additionally, its flat underbelly design makes it susceptible to improvised explosive devices and landmines. Crew survivability is enhanced with spall liners to reduce secondary injuries from shrapnel and an automatic fire suppression system to contain fires from internal explosions. The Puma, on the other hand, sets a new standard in armor protection for modern IFVs. It uses a modular armor system, allowing operators to adjust the level of protection based on mission requirements. In its baseline configuration, the Puma provides protection against 14.5 mm armor-piercing rounds and artillery shell fragments. In its maximum armor configuration, the Puma can withstand 30 mm autocannon rounds, anti-tank mines, and even modern anti-tank guided missiles. This flexibility allows the Puma to adapt to different combat scenarios without compromising mobility. The Puma also features blast-resistant seating for both the crew and infantry soldiers, reducing the risk of injury from explosions underneath the vehicle. Its spall liners, automatic fire suppression system, and NBC protection system further enhance survivability in high-threat environments. Overall, Puma offers significantly better armor protection than the M2 Bradley, especially against modern anti-tank threats and high-caliber autocannon fire. Regarding reconnaissance capabilities, the M2 Bradley is well-suited for reconnaissance missions, particularly in its specialized variant, the M3 Bradley Cavalry Fighting Vehicle. Equipped with advanced thermal imaging, day optics, and laser rangefinders, the Bradley can effectively detect, identify, and track targets even in low-visibility conditions. Its command and control systems enable real-time data sharing with other units, making it highly effective for surveillance and forward reconnaissance. Additionally, its TOW anti-tank missiles and 25 mm Bushmaster chain gun allow it to engage enemy units if detected during a reconnaissance mission. However, the Bradley's large profile and relatively heavy armor make it less stealthy, reducing its ability to conduct deep infiltration reconnaissance missions without being spotted. The Puma, on the other hand, excels in both reconnaissance and survivability capabilities. It comes equipped with an advanced sensor suite, including third-generation thermal imaging cameras, panoramic periscopes, and high-definition optical systems. These sensors allow the Puma to perform long-range surveillance and target identification with exceptional clarity. The digital battlefield management system ensures seamless communication with other units, enhancing its role in network-centric reconnaissance operations. Its low thermal and acoustic signatures make it more stealthy compared to the Bradley, enabling it to operate discreetly in enemy territory. Overall, while both IFVs have reconnaissance capabilities, the Puma surpasses the Bradley in terms of sensor quality, stealth, and overall survivability. Regarding cost, the M2 Bradley has an estimated unit cost of around $3 million to $4.5 million per vehicle, depending on the variant and specific upgrades included. The relatively lower cost is primarily due to its older design, which has been in production since the 1980s, allowing for economies of scale and reduced research and development expenses over time. Factors contributing to the Bradley's cost include armor upgrades, weapon systems, and modern sensor packages added in recent years to maintain its battlefield relevance. On the other hand, the Puma is significantly more expensive, with an estimated unit cost of $7 million to $12 million per vehicle, depending on its armor configuration and additional systems, such as Spike-L, or anti-tank guided missiles, or advanced communication suites. The higher cost stems from cutting-edge technologies, advanced modular armor systems, state-of-the-art fire control systems, and highly automated features integrated into the design. The M2 Bradley has seen extensive production since its introduction in the 1980s, with over 6,700 units manufactured across various variants, including the M2 and M3 models. The Bradley has been a cornerstone of the U.S. Army's armored forces and has been widely deployed in major military operations, including the Gulf War 1991, the Iraq War 2003 to 2011, and operations in Afghanistan. It played a crucial role in urban warfare, reconnaissance missions, and frontline troop support. Currently, the M2 Bradley remains in service with the U.S. Army and National Guard and is actively deployed in Europe to deter potential threats from adversarial forces. While the Bradley was primarily designed for the U.S. military, it has not been widely exported. However, Saudi Arabia operates an estimated 400 M2 Bradleys, and smaller numbers have been delivered to nations like Lebanon and Croatia through U.S. military aid programs. On the other hand, the Puma is a relatively newer platform, with approximately 350 units produced since its induction in 2015. All Puma IFVs are currently. In summary, while the Bradley excels in proven performance, global deployment, and affordability, the Puma outshines with its modern design, advanced survivability, and network-centric capabilities. Both IFVs serve their respective militaries with unique strengths and specialized roles, highlighting the difference in design philosophies between American robustness and German precision engineering. Which one do you think has the edge in modern combat scenarios? Let us know in the comments below. That's it for today's comparison. Make sure to like, share, and subscribe for more defense updates and comparisons. See you in the next video.